Oh, that looks terrible. That looks bad. Generalizing from what we know to what we don't, as well as being able to mind. As well as being to learn about what causes what. Children also to transfer. That's the last one. They have learned in one context to another. This fundamental aspect of learning means we aren't perpetually surprised at every new situation because we have formed expectations of how categories of things will behave. For example, if my pet dog needs to eat and sleep, then maybe all dogs need to eat and sleep. If dogs need to eat and sleep, then maybe cats do too. Maybe all animals need to. This kind of generalization can be incredibly powerful because it allows us to go beyond our direct experience and to get some information about the world for free. I don't need to have met every dog in the world in order to expect they also need to eat and sleep. Developmental psychologist Iowan Guion, Joshua Tenenbaum, and Laura Schwartz were interested in understanding exactly how babies learned to generalize from the experience. Guion et al. 2010. They tested 130 15-month-old by placing them in front of an experimenter who would pull coloured balls out of a box, figure 5.3. The box had a transparent front so the babies could see roughly how many balls of each colour were inside the box. In the first condition, infants saw the experimenter draw out 3 blue balls in a row. The experimenter then squeezed the blue balls, demonstrated they squeezed, and then handed a yellow ball to the infant, saying, "Now, this one for you to play with. You can go ahead and play." When the box mostly contained blue balls, the infants were also squeeze their yellow ball and make it squeak. Presumably, the infants were reasoning that 3 blue balls drawn from a box containing mainly blue balls is a plausible random sample, and if you can reach into the box at random and pull out things that squeak, then maybe everything in the box squeaks. In the second condition, the experimenter showed the infants a different box containing mainly yellow balls, and again withdrew 3 blue balls. In this case, it is not a plausibility. Randomly sample. Maybe these balls have been deliberately selected and something is special about them. Maybe only the blue balls squeak. In this second condition, despite the same invitation to play, infants were significantly less likely to generalize from their experience by squeezing the yellow ball. Laura Schultz and her team concluded that 15-month-old babies in this respect are like scientists. They care whether the evidence is randomly sampled or not, and they use statistics to guide their generalization about the world. What squeaks and what doesn't, what to explore and what to ignore. The implications of this research, of course, go well beyond learning about which ball squeaks. Generalizing from what we know to what we don't is something infants do all the time, making influence about objects, people, and animals, and creating their own explanations of the world. The power of generalization goes a long way to explaining how we can learn so much in such a short time. A wide body of research suggests toddlers and preschoolers explore the world and collect new information in these systematic and evidence-based ways. Ronford et al. 2018, Schwartz 2012. This is another example of how children are not passive recipients in their learning, but able, active participants. As such, parents and caregivers don't have to teach young children so much as they have to let them learn. Gottnick, 2016. Children can transfer what they have learned in one context to another, generalizing in systematic and evidence-based ways. Play. There is perhaps no better example of exploratory learning than play. Play is a common behavior among young animals for a wide range of species, and it provides a safe space to practice many of the skills that will be important later in life. In studies that have deprived rats of opportunities to play early in life, they grow up to be less sensitive and flexible in the way they respond to other rats than rats who are allowed to play. Van der Schorsen et al. 2016. The general message from animal studies is that play is important not because it teaches one skill in particular, but because it builds general purpose problem solving skills, flexibility, and resilience for the future. Or as Marek Spinka, an expert in animal behavior and welfare, put it, play is training for the unexpected 2001. The implications of this research for human development are important. For example, in education, policymakers are under pressure to demonstrate the benefit of scheduling play into a busy curriculum. But the long-term benefits of play for children may only emerge long after they have left the classroom or school, and even then they are difficult to quantify. Humans have taken play one step further than most other species and engage in pretend play. In its simple form, this begins to emerge by around 12 to 18 months of age by pretending a wooden block is a teacup, for example, but it can develop into elaborate fantastical scenarios played out with the aid of props, language, or gestures. Observe almost any 4-year-old, and it won't be long before they are engaging in some kind of pretend play. But the ordinariness of this also raises a question. Why would children spend so much of their time and energy engaged in make-believe when it might be better to understand how the real world works? To say that it is fun only pushes the question further back. Why is it fun? Psychologist Daphne Buxbaum and her colleagues have argued that pretend play has a especially important role in children's ability to reason counterfactually. Baxborum et al. 2012. Counterfactuals involve a mental simulation of what if. For instance, if I had turned up to the job interview without trousers, I would have been embarrassed. If I had revised harder, I would have passed the test. Or if my grandmother had wheels, she'd be a bicycle. The ability to think counterfactually represents the most advanced stage in children's understanding of cause and effect. At first, children merely observe cause and effect in the world, e.g., seeing a toy fall off a table when pushed. Then they intervene in the world to cause an effect, pulling a toy towards them. And finally, they imagine what could have been, e.g., if I had pulled a different toy towards me. That would have been better. Counterfactual thinking also underpins more moral sentiments like regret, blame, responsibility, and credit. And experimental evidence suggests that children as young as 5 years of age use counterfactual reasoning to make moral and social judgments of others. Gorton et al. 2023, Wong et al. 2023. Both pretend play and counterfactual reasoning consider events that have not occurred. They separate imagined events from reality and simulate what would be the case if such imagined events had occurred. This skill allows us to imagine past worlds that never were, or run simulations of possible futures, or ability that has sometimes been refused to mental time travel. Buxbaum argues that just a physical play provides young animals with opportunity to practice skills that they will need later in life, like how rough and tumble prepares animals for fighting. Pretend play lets children practice the cognitive skills necessary for casual learning, planning, and counterfactual reasoning. To test this idea, she said her colleagues asked 52 children aged 3 to 4 years to engage in some pretend play with them. They substituted a real machine, similar to the blanket detector we met earlier, for a white wooden box and 2 coloured blocks. The experimenter explained, I thought we would pretend that the box is my machine and that this block, one of the coloured blocks, is a Zando, and that this block, the other coloured block, is not a Zando. The children then took part in a counterfactual task that involved working out what the machine would do in different scenarios. For example, the experimenter asked the children, if this one were not a Zando, what would happen if they put it on top of the machine? Bushbaum et al. 2012. All the children were able to successfully take part in the pretend play appropriately and answered correctly regarding the counterfactual. But there were some variation in how they did so. The researchers found that the children who were especially good at pretend play were also the ones who were good at counterfactual reasoning tasks. This kind of association of what we would predict if pretend play was related to counterfactual thinking, as Bushbaum suggests. Furthermore, the researchers showed that children transferred their knowledge from the pretend task, e.g., playing with the wooden machine, in order to perform correctly in the counterfactual tasks, e.g., predicting what a non-Zando would do to the machine. In other words, pretend play helped them in their counterfactual reasoning. It seems to go against the very nature of play to ask what it might be for. Play, as we usually think about it, isn't designed to achieve anything. If it were, it wouldn't be play, nor would it be so much fun. Gottnick 2016. Precisely because play isn't designed to achieve anything in the here and now. We need a way to motivate us to engage in it. Making play fun might be one way to make exploration enjoyable for its own sake. The evidence suggests that play, and in particular pretend play, provides a mental training ground for reasoning about and learning from imagined scenarios that can later be applied to real ones, such as learning to regulate aggression and practice conflict resolution in culturally appropriate ways. Pellegrini, 2009. More generally speaking, play provides the space to imagine how things would behave in imaginary worlds, and this powerful ability allows us to adapt to and anticipate a wide range of alternative possible future environments. Humans, as we know, also have a longer period of childhood than most other species, which means we get more protected time for play and so can benefit from it to a greater extent later in life. Figure 5.4. Key points. Play and pretend play help children practice the physical and cognitive skills they will need later in life. Pretend play shows that children have powerful imaginations, but will they believe anything? Research suggests not. See box 5.1.